So welcome students. In this video, let us look at the first and the most important rule in triangles, which is called sine rule, which says that A by sine A is equal to small b by sine capital B is equal to small c by sine capital C is equal to 2 times the circumradius. The side A by sine of the angle opposite to side A is equal to small b by sine B is equal to small c by sine C. That is, this side by sine of this angle is equal to this side by sine of the opposite angle is equal to the third side by the sine of the opposite angle. And all these three ratios will be equal to 2 times the circumradius. This is the theorem. So let us see why this theorem works. And after that, let us see how this theorem can be used to solve problems. So first, let us take a triangle ABC. If you take any triangle ABC, there can be 3 cases. ABC can be an acute angle triangle, a right angle triangle, or an obtuse angle triangle. And in these 3 cases, let us prove that A by sine A is equal to 2R. Whatever may be the nature of the angle A, if you show that A by sine A is always equal to a constant 2R, obviously by symmetry B by sine B and C by sine C will also be equal to 2R. Now, first let me take an acute angle triangle. So if you take an acute angle triangle, obviously the circumcenter lies inside the triangle. Now, how can I prove that A by sine A is equal to 2R? I use certain properties of circles. So first what I do is I'll draw a diameter through B. So I'll draw a diameter through B. So if this is capital R, this is also equal to capital R, right? Now let this point be P. I'll join PC. Now we have a standard property in circles which says that angle in the same sector is equal. That is, the chord BC is subtending an angle of A as well as P on the same sector. Hence angle A has to be equal to angle P. So angle P has to be equal to angle A. And because BP is the diameter, this angle has to be equal to 90 degrees. Angle BCP has to be equal to 90 degrees. These are the 2 conclusions that I draw. First is angles in the same segment are equal. The second is angle in a semicircle is equal to 90 degrees. Now, in this right angle triangle, what is sine P? Sine of P is nothing but opposite side by hypotenuse. So in this triangle BCP, which is a right angle triangle, BP is the hypotenuse, A is the opposite side to P. So A by the hypotenuse is nothing but 2 times R, which is the diameter. And this implies angle P is exactly equal to angle A. So sine of A is equal to A by 2R. This implies A by sine A is equal to 2R. So I have taken an arbitrary vertex and an arbitrary opposite side, and I have proved that this side by sine of opposite angle is equal to 2R, which is a constant. So by symmetry, B by sine B and C by sine C should also be equal to 2R by a similar derivation, so which you can do. So A by sine A is equal to 2R works if angle A is acute. Now let us see whether it works if angle A is a right angle triangle. So let us say that angle A is a right angle triangle. So obviously the side opposite to A should be the diameter. So this is R and this is R. Now what is small a? Small a is equal to 2R. So small a by sine A is equal to 90 degrees. So sine A is 1 should be equal to 2R. Because if this is 90 degrees, sine A is equal to 1. So A by 1 will always be equal to 2R. Because the side opposite to capital A is BC, which is equal to 2R. So that means If A is a right angle, also A by sine A will be equal to 2R. So now let us see if the same result holds if A is an obtuse angle. So if A is an obtuse angle, obviously the circumcenter will lie outside the triangle. Now if the circumcenter lies outside the triangle, so you can always draw a diameter from B. Let us say it as BP. Let the center be S. And if you join P to C, the angle will be 90 degrees because angle in a semicircle is 90 degrees. Now BPC is a right angle triangle and ACPB is a cyclic quadrilateral. Do you remember any properties of cyclic quadrilaterals? Yes, the sum of opposite angles have to be equal to 180 degrees. So angle P has to be equal to 180 degrees minus angle A. So let us say this equal to theta. So let us say this as theta. So now in this triangle, this is capital R, this is capital R, and this side is the side opposite to A. So this is small a. So what is sine theta? Sine theta is equal to opposite side A by 2R. And what is theta? Theta is 180 minus A. So sine of 180 degrees minus A is equal to A by 2R. What is sine 180 minus A? It's nothing but sine A itself. This is 2 into 90. It's in the second quadrant and the number is even. So sine becomes sine. So sine A is equal to A by 2R. And this implies A by sine A is equal to 2R. So whether A is acute, A is a right angle, or A is a obtuse angle, A by sine A will always be equal to 2R. By similarity, B by sine B will also be equal to 2R and C by sine C will also be equal to 2R. That means in a triangle, this sine rule always works. And what is the importance of sine rule? So the sine rule says that the ratio of the sides ABC is same as the ratio of the sines of the angles opposite to them. So sine rule gives you the ratio of the sides of the triangle. So if you have a triangle whose angles are 30 degrees and 120 degrees. So we have three angles as this. What is the ratio of their sides? The sides will be in the ratio of their corresponding sines. That is 1 by 2 is to 1 by 2 is to sine 120 is root 3 by 2. So the sides will be in the ratio 1 is to 1 is to root 3. This is one result which gives you the ratio of the sides if the angles are known. So let us take an example where sine rule can be used. So in the question you're given that the perimeter of a triangle is 6 times the arithmetic mean of sines of the angles, and the side opposite to vertex A is equal to 1. You're asked to find the angle A. So you can solve this using the basic formula. So the perimeter of a triangle is nothing but A plus B plus C is equal to 6 times the arithmetic mean of sines, that is sine A plus sine B plus sine C by 3. The sum of the sides of the triangle is equal to 6 times the arithmetic mean of sines. So this cancels out 2 times. Now one side you have the sides, the other side you have the sines. The sine rule connects the sides with the sines. So we know that A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R. So small a is equal to 2R sine A, small b is equal to 2R sine B, small c is equal to 2R sine C. So this implies A is equal to 2R sine A. So in all these you have 2R common. So 2R times sine A plus sine B plus sine C is equal to 2 times sine A plus sine B plus sine C. So these two are getting cancelled. So this 2 and 2 also are getting cancelled. This implies R is equal to 1. So from the first information you got the circumradius as equal to 1. Now once you have this, you have the side, you can easily find the angle. So we know that A by sine A has to be equal to 2R. This implies 1 by sine A has to be equal to 2 into 1 is 2. This implies sine A is equal to half. This implies A is equal to 30 degrees or 150 degrees. So the angle A can either be 30 degrees or 150 degrees. These are the two possible answers for this question. So let us take another example. So in this question you're given that angle A is equal to 75 degrees, angle B is equal to 45 degrees. And you're asked to prove that B plus C root 2 is equal to 2A. So you're given two angles, that means effectively you're given all the three angles because the sum of angles is 180 degrees. So if angle A is equal to 75 degrees and angle B is equal to 45 degrees, so angle C will be equal to 180 minus 75 minus 45. 75 and 45 combinedly gives you 120. So the remaining angle is 60 degrees. And once you know the angles, what does sine rule say? A by sine 75 degrees is equal to B by sine 45 degrees is equal to C by sine 60 degrees is equal to 2R. This implies A is of the form 2R sine 75 degrees. Sine 75 is nothing but root 3 plus 1 by 2 root 2. That is equal to R times root 3 plus 1 by root 2. Next, B is of the form 2R sine 45 degrees. 2R sine 45 is 1 by root 2. That is equal to R times 2 upon root 2. And C will be equal to 2R times sine 60 degrees. 2R times root 3 by 2. That is equal to R times 2 root 3 by 2. 2 root 3 by 2. So this is how ABC looks in terms of R. Now you're asked to find this. You're asked to prove this. So let us take the LHS and the RHS and see whether both are same or not. So if you take the LHS of this left hand side, so B plus C root 2 is nothing but B plus C times root 2. That is R times 2 by root 2 is root 2 plus C times root 2. If you multiply this with root 2, you get 2 root 3 by root 2. That is equal to R times 2 plus 2 root 3 by root 2. That is equal to 2R times root 3 plus 1 by root 2. Or I can write this as, I can leave it here. So, and you can very clearly see that R times root 3 plus 1 by root 2 is nothing but A. So I can write this as 2 times A, which is nothing but the RHS. So from LHS, I have gone to RHS, and this result is proved. Thank you.